example based on type 1, type 1 of non-homogeneous higher order differential equation, but they are linear. Linear means, look at the highest order derivative by its degree. Its degree is always 1, means it's a linear differential equation of higher order. Dependent variable is y, independent variable is x, and since the right side is exponential means it is type 1 example. As usual, to solve this, the steps are: first you need to express in the standard form, second step you need to find out complementary function, third one you need to find out particular integral, fourth one you need to club both complementary function and particular integral. So now first I am going to express in standard form. So for that, substitute d square by dx square by capital D square and d by dx by capital D. Then the other equation becomes 6d square y plus 17 dy plus 12 y is equal to e raised to minus 6. Further, I am going to take y is common on the right side. The 17d plus 12 into y is equal to e raised to minus 6. So this is in standard form. Standard form of non-homogeneous f of t into y is equal to phi of x. So let's go to find out the auxiliary equation. What is the auxiliary equation, student? We need to substitute in the standard form. D is replaced by m. So it will become 6 times of m square plus 17 times of m plus 12 equal to 0. So it is a quadratic equation, and remember you neglect y and exponential term. So you get a quadratic equation. We have two methods to solve quadratic equation. One is factorization, another one is reverse formula. Okay. So we are using again factorization method. 12 6 72. So if you express 72 as a 9 into 8, what is 9 into 8? 72. So 72, 9 plus 8 is 17, right? So therefore you can easily factorize. You can write 6m square plus 17m can be written as 9m plus 8m plus 12 is equal to 0. In the first two term, take what is common here? 3m is common. You will get 2m. 3 2s are 6. m into m is m square plus 3. Isn't it? 3m into 3 is 9m plus here also. What do you take common? 4. 4 take common. 4 2s are. 4 2s are 8m plus 4 3s are 12, right? So therefore 2m plus 3, 2m plus 3 are the factors. Take 2m plus 3 common. What will you get? Here you get 3m plus 4 is equal to 0. Okay. So take each factor equal to 0. 2m plus 3 equal to 0. 3m plus 4 is equal to 0. You get 2m is equal to minus 3. M is equal to minus 3 by 2. And 3m is equal to minus 4. M is equal to minus 4 by 3. And look at the roots are different. In case of different root, we write complementary function yc as c1 e raised to first root minus 3 by 2 into x. I told you already. Y is dependent, x is independent. Previously it was different. Plus c2 e raised to minus 4 by 3x. We are writing the two roots separately and the two constants separately. Okay? Fine. So this is the complementary function. Let's find out yp. What is yp? You know already. In standard form, keep it y as this and you cross multiply this into right side. The right side e raised to minus x is present in the numerator and cross multiply this. You will get 6d square plus 17d plus 12, isn't it? Okay, fine. Now, as you know already, type 1 example. What is type 1 example? We'll go back again. Type 1 means numerator is exponential divided by function of d. In such a case, how to find out particular solution? We keep it exponential function as it is. In the denominator, d is replaced by this value a, isn't it? So we are going to replace d by a. What is the value here? Minus 1. Okay, fine. So what is yp? Yp is equal to e raised to minus x divided by 6 into minus 1 whole square plus 17 into minus 1 plus 12. E raised to minus x divided by minus 1 whole square is positive. 1 into 6 is 6. The 17 into minus 1 is minus 17. 6 plus 12, 18. 18 minus 17 is 1. So yp is just e raised to minus 6. Finally, what is general solution? General solution is y is equal to yc plus yp. What is yc? c1 e raised to minus 3 by 2x plus c2 e raised to minus 4 by 3x plus e raised to minus x is yp. Is it correct? So let's look at again, these are correct, right? 3m plus 2m plus 3, 3m plus 4. Okay. So that's it. We have discussed two examples on type 1. One example is completely based on assignment. Okay. Second one is for your reference. Thank you.